All right, so to restart that, sorry about that. So on Monday, we will not be, or my fault, Monday. On tomorrow, Friday, we won't be doing Alex. We're going to be doing some extra practice problems, so that way we can get ready for our assessment. Okay, next week on Thursday, right before our 3-day or our break, we are going to have a summative assessment. Okay, we're going to be testing over dilation and triangle similarity. So everything we've been learning since the beginning of the semester, we're going to be testing over on Thursday. So next Thursday?
Did we get to use the packet?
Yep, in a week. And then that means on Tuesday and Wednesday we will be reviewing, and Monday is going to be our last day of new content. We saved that last day of content to be one of the more easier topics to talk about, okay? Which is the coordinate plane dilations from the center of origin. Okay, but we'll get to that tomorrow and next week. At this moment, we got to go ahead and do these similar triangle examples. So, our three triangle similarities are angle-angle similarity, side-angle-side similarity, and side-side-side similarity. We make sure that our angles, when we have angles, are congruent. And then when we are talking about sides, we need to make sure that the corresponding sides are proportional. The hardest part of these problems is finding which sides are corresponding, right? A lot of times, or sometimes, some triangles can be drawn inside of each other, which makes it hard to find corresponding sides, or maybe the triangles are too close together, so it's hard to find corresponding sides. For example, right here, these two triangles here, we didn't really know which one to do, if A went with E or B went with F or vice versa, but we figured out that, hey, that point, this one doesn't really matter because it's an isosceles triangle, and there could have been a reflection in the middle or something, so that one did not really matter. But we'll have more common things like this where it's easier to see what is corresponding and not. Okay, so let's go ahead and flip to the back page. We're going to do two of these, and then we're going to go ahead and move on to our final idea. Okay, so what I want to do is I'm going to go ahead and do question E. And you want to do C as well? We'll do C and E. That's perfectly fine with me. Let's do C first. Okay, so I'm looking over here. I have parallel sides. What do parallel sides tell me? What am I going to be looking for within the parallel sides with a transversal? Right? If you guys remember, we're not doing D, so I'm going to draw a little bit of a transversal here. Right? Remember when we had parallel lines that were cut by a transversal, we had alternate interior angles have to be equal. Okay, so if I extend this out, if I extend these lines out, and I make this my transversal, my T, my transversal, my parallel lines are on the side, so that means that this inside angle and this inside angle have to be congruent. All right, so this is angle J is congruent to angle G by alternate interior angle theorem. Okay, now I could go ahead and do the other line as well to do another angle, to get angle-angle using alternate interior angle theorem, or I can do the two middle angles using the vertical angle theorem. Both of them would work either way, up to you which you decide. Okay, I'm going to go ahead and do my vertical angles. So vertical angles. So that means that angle FHG is congruent to angle KHJ. So are these triangles now similar? We have two pairs of angles. So I'm looking back at my triangle similarities. Is there one that says if we have two pairs of angles, congruent to two pairs of angles, then they have to be similar? Okay, I'm seeing some head shakes. Which one is that one? Okay, Brindley said angle similarity. Brindley, can you do me a favor? Can you give me a number 1 through 7? 4. Thank you. Okay, so I agree with Brindley. This is an angle similarity.
With who?
type? Brindley.
Yeah, you said like Bentley.
No, I said Brindley. In my head I said Brindley. If it sounded like Bentley, I'm super sorry. I meant Brindley though.
You look like a guy.
All right, now we need to write our similarity statement. When we write a similarity statement, we have to put the corresponding angles in the same position. So let's start with triangle. Let's do GHF is similar to triangle. Angle G was my one arc mark. My one arc mark over here was J, so my J needs to go first. My H is the middle, 2 tick marks. H is the middle, 2 tick marks, so H needs to be my second letter. F is my last letter, which means K must be my last letter in the positions. So triangle GHF is similar to triangle JHK. Alrighty. Any questions about example problem C? Alrighty. So now we're going to go to E. Nice stuff, man. Nice stuff, man. Okay, I'm looking at this, and this line XY looks like it was dilated to become BC, right? With the center at A.
Yep.
So this dilation would have to mean that we probably have parallel lines right there. So go ahead and mark that those lines are parallel for me. Okay, this is going to be coming into our side splitter theorem eventually, okay? Now we have two triangles. We have the smaller triangle on top and the bigger triangle that includes the smaller triangle. So what we need now is the distance of the long triangle side. So I'm going to go ahead and put a mark like this, right? This idea, or this little line with the end brackets, this tells us that we're measuring that distance. So this distance from AC will be 25 plus 30. 25 plus 30 is 55. On this left side, AB will be 20 plus 25, which is 45. So this will be 45. Okay, so we have two pairs of sides that we're going to be, we have two pairs of sides that we're going to be putting in a ratio to see if they're proportional. We're missing a piece of information, right? Our options are angle, angle, side, and side, side. We don't have an extra side, so that means we are either going to have to use angle, angle, or side, angle, side. But we already have sides. So that only leaves one option for us. So 1, 2, 3, 4. Cam, what is our last option for this similarity type? Okay, so like we said, we have two pairs of sides, and we don't have our third side. So let's look over here. Which one tells us to use two sides and not a third side?
Side.
Well, side, we would need a third side, sir. Do we have a third side? So then we would need to use side, angle, side. Thank you, Cam.
Hey, Mr. Rob, I have a question. Is 12 over 9 the simplest form?
No, both of those can be divided by 3.
So it would be 3 over 1.
4 over 3. 12 over 9 is simplified to 4 over 3. Okay, so we are going to try to use side, angle, side. But we are missing an angle that is similar. Okay, 1, 2, 3, 4. Chase, sir, we're on problem E right now. Can you turn back to problem E just for a second?
Turn back to the problem E.
Yes. I know this was a little bit a while ago for you. You already did this one. Appreciate that.
Big green girl.
Okay.
What am I doing?
I want to know, I need the angle so that we can use side, angle, side. What angle are we going to be using for question E? I'll zoom in, sorry. All right, we want to use side. Did you use side, angle, side for question E? Used angle, angle?
The angle, yeah, that's what I've done.
Ah, okay.
But at first I had side, angle, side, but then we erased it and decided as
Okay, so this one you might want to fix it in your book, your packet then. This should be side, angle, side.
What was the question?
Okay, so if we want to use side, angle, side, we have our two sides on the outside here.
Yeah.
We're missing our angle. Which angle would that be? Which angle can we say is congruent to each other?
Oh, XB is congruent to YC, but then AB is congruent to AC. What am I, like?
We're on angles now. Those are sides.
I don't know angles.
Angles?
B and C? B and C are congruent.
B and C is a line, sir.
No, B is an angle and C is an angle.
So angle B, angle C. Are these going to be the exact same, though?
Yeah.
How do you know?
I don't know.
Okay. Do you need me to ask someone else, sir?
I don't know. B and Y, right?
Okay,
I'm like
B and
looking-
Y.
I
Okay, so that's fine. I like that you're processing, trying to get to place,
Brain ain't
okay?
doing this early.
Well, let me ask you this, though.
Brain
This
not
smaller
brain.
triangle is placed right on top of the bigger triangle, right?
Yeah.
And there's one angle that is flushed with the bigger triangle.
Yeah, the 25 one.
25 is an angle?
You're,
25 is a
if you
side,
think
sir.
about it, it is.
It's
Are you
not.
throwing things at me?
Okay, so we have either angle A, X, or Y. Angle A, X, or Y. Which one of those is right on top of the other angle for the bigger triangle? Angle A. Right here, angle A is going to be congruent to angle A. This is that reflexive property, right? An angle or an object is equal to itself. This is the same angle for both triangles, so they are equal to each other. So we have that the angles are congruent. Now we need to make sure that these sides are proportional. Okay, so let's make sure that these sides are proportional. So I'm going to do this left side over 20. So it will be 45 over 20. And then we need to make sure that this is equal to 55 over 25. Okay, I'm looking at this. They end with 5. So I'm going to divide everything by 5. So divide by 5, divide by 5, divide by 5, divide by 5. 45 divided by 5 is 9. 20 divided by 5 is 4. 55 divided by 5 is 11. And 25 divided by 5 is 5. Are these side lengths proportional? Are they equal to the same ratio? Do they simplify to the same thing? Is 9/4 equal to 11/5? No. So what does that mean for us?
It's not whatever.
It is
it's
not
called.
possible,
It's not
right?
possible.
That's why your answer was not possible, right? So that's my fault. So you were correct in the end run. We just didn't see it for us since we're just starting. So the similarity type is not possible. Why is it not possible? These sides are not proportional. Oh, I spelled this backwards. It's P-O-R-P-R-O, proportional. It does look like that now. Okay, so the sides are not proportional, so these are not similar triangles. So this one is just not possible. Okay, so I need your guys' feedback. Can you guys give me a thumbs up if, hey, I think I can identify similar triangles using angle-angle similarity, side-angle-side similarity, or side-side-side similarity? Okay, put your thumbs sideways if I can try. I can do a couple of them, but some more practice is needed. And then thumbs down if I have no idea what similar triangles even means. Okay, so you please give me a thumbs up, thumbs sideways, or a thumbs down.
I understand most of them, but
Okay, so we're gonna need some more practice so that's why we're doing no Alex tomorrow, so we can get some more practice going, okay? Alrighty, so we're gonna put a pause on triangle similarity, and we're gonna go ahead and go to the side splitter theorem. Okay, so turn your packet page a few times.
I'm gonna know what this is like.
Okay, and we are going to go to this side splitter theorem. Okay, this is going to be triangle 1, this is going to be triangle 2, and this is going to be triangle 3. Okay, what the side splitter theorem tells us is that if a line is parallel to one side of the triangle and intersects the other two sides, then it divides those sides proportionally. Okay, it divides those sides proportionally. So we have a few options here. Okay, this in all its idea is simply a dilation, right? We dilate this middle line to this outside line from this top point. Okay, and when we do dilations, we can set proportions up to the side lengths that we have. So the first proportion that we can set up, okay, is A over B must be equal to C over D. Or the vice versa. B over A has to be equal to D over C. Okay, so if we ever see triangles where the bottom sides are parallel and we have all four distances, this must be true. Okay, this also works backwards as well. If the sides are divided proportionally, then that means we have similar triangles, right? So we're able to prove using this as well. So this is our final idea for being able to solve. So the reason that the side splitter theorem is useful is to solve for missing side lengths. Okay, and that's pretty much what is going to be for our examples. Okay, so that's our first one. Our second one that we can do is, let's say that all of this, A plus B, was equal to X, and all of this, C plus D, was equal to Y. All right, hey Nathan, sir, could you knock that off? Appreciate that. Okay, so what we are able to do is we can do X over A has to be equal to Y over C. Notice I just used the side of the small triangle here, right? The side of the small triangle. Okay, or you can do it vice versa as well, as A over X has to be equal to C over Y. Okay, and lastly, the exact same idea. Let's make this left side X. Let's make this right side Y. And the last thing that we can do is we can do X over B has to be equal to Y over C, or the reciprocal B over X must be equal to C over Y. Okay, remember X and Y are the addition of those two side lengths that we have. Okay, now we should be able to use these to solve for missing sides. Okay, so let's go ahead and do an example of this. Okay, does everybody have these 3 to 6 equations written down? Right, because you only need these 3, the first 3, because you'd be able to just flip them over and they're the exact same. Okay, everybody got them? All right, let's go ahead and go to our first example. So I'm looking here, I have 2 and X for my smaller, or my bigger, or my smaller triangle, and then 8 or 6 and X plus 7 for my bigger triangle. Okay, so I'm looking at this information. Which one of my ideas here, or which one of my side splitter theorem equations should I be using? Okay, am I adding my sides together on this question? Right, so the question down here, will I need to add my sides here? No, right? So that means I could probably use this top one right here, where A and B are 2 and 4, and C and D are X and 7. So if you want to write that, we can say AB down here, CD down here, and we know that A over B has to be equal to C over D. And now we can plug in our numbers, right? This A over B is equal to C over D. I got that from right here, my first side splitter theorem equation.
I have a question.
Yes, sir.
So, I kind of just tested it. So 2 goes into 7 3 times, right?
Okay.
It doesn't equal 7, but
But it goes right before
so
overfilling.
It would be the denominator. And then 2 times 2 is 4. So 2 would be on the top. and I tested it on a different triangle and it got me the answer again. Would that happen every time?
One more time, repeat that. So 2 is
goes
just
into,
because 2 is not a power
so,
line.
Yeah, so 2 goes into 7 3 times. So that'd be, I put that as the denominator.
So would you put it as a 2 or 7?
I put 3 as the denominator. So 2 goes into 7 3 times. So 3 as a denominator, and then I put, because 2 can go into 4 2 times, so I put that as a numerator. So it's 2/3, and I'm pretty sure that's the correct answer.
For our x?
Yeah, but I'm not for sure.
I'm not too sure. Let's see if we get the same answer at
I
the
don't
end.
know.
See if we get the right one, all right? So let's go ahead and plug these in. A is 2, B is 4, C is x, D is 7. I now need to do my cross products, right? This is why we have the proportions at the front of the page in case you need that extra practice. Okay, so solving proportions, we do cross products. We have 4x is equal to 14. Divide by 4, divide by 4. That means our x is equal to 14 over 4. Dividing everything by 2, which will equal 7 over 2. Was that what you got? That was not what you got. You got 3 over 2, right?
Yeah.
So then your method did not work, sir. So that means our x here is equal to 7/2, which is equal to 3.5. Okay, since we're dealing with distances now, I feel like distances are better with decimals. Okay, so fraction or decimal answer here, either one will be okay. I will look for both of them. So this one not too bad, right? Just using the equation we have, plugging into that equation, solving for that missing variable. Any questions on this first example together that we did? Alrighty, let's go ahead and go to the example to the right. So I'm looking here, we're trying to solve for the whole side of the big triangle, which is labeled as W. Excuse me. So going back to my equations, to know the full distance, I need to know the other full distance as well, right? So the only ones with full distance were the second and third triangle, where we had the x and y, x and y. I need to know the distance of both sides. So for this example, we have one side being W. I now need to know what my other side is equal to. 21 plus 6 is equal to 27. Okay, or one way we can think of this is actually W minus 8. So there's actually more than one way we can think of this. So what we can do is use the big sides, or again, we can just use the smaller sides since we know this is actually equal to W minus 8. So which ones do you guys want to do? Do you guys want to do something like 2 and 3 equations where we add the x and y for the whole sides? Or do you want to just use our first triangle equations where we just use the parts of the sides of triangles?
Actually, we tried the full side.
The full side length. So we get that example? I agree. So we're going to use either 2 or 3. Doesn't matter which one we use.
What's the difference between 2 and 3?
Nice. That's a good question. The difference is what we divide by. The first one is A, the second one is B. A and B are up here, right? The next one is C. Oh, this should be D. My fault. Thanks for making me explain that. That should be a D, not a C. Please change that if you wrote that down for me, okay? Should be a D. Okay, please change that from a C to a D.
So for 3, we're just doing the bottom.
Yeah, so for 3, we're just doing the bottom ones, for the bigger triangle. But let me ask you guys this. If I were to do the big one and then the bottom one, I would have 2 W's. Oh, you guys can't see that. Sorry. Right? So this would be, let's say this is my A, this is my B, this is my C, and this would be my D. Right? If we were to use the Y and the D, I would have W over W minus 8. And that's not fun at all. So what I'm going to do is I'm going to do it with my C. Right? I'm going to look for the one that has my C, which is up here. So it'll be X over A plus Y over C. I'm going to make this 27 my X, and I'm going to make this W my Y. Okay, so we want X over A is equal to y over c. My x, my whole distance added up, is 27. So we will have 27 over my a is 6. Now this should be equal to my whole distance, which is w, over my c, which is 8. And now I do my cross products to solve for my w. So 6 times 8, 27 times, or 6 times w, my fault. Misspoke. 6 times w times 27 times 8. So 6w is equal to 27 times 8 divided by 6 divided by 6. W is equal to 27 times 8 divided by 6. I cannot do 27 times 8 in my head.
16.
27 times 8 is 216. 216 divided by 12. Oh. 216 divided by 6. It is 108. Did you guys get 108 as well? Why is that so big?
That's what she
Not-
Doors that way.
Yeah, let's not say that, sir.
I got 36.
Yeah,
36.
16 divided by 6 is 36.
Ah, okay, that makes more sense. So W is equal to 36. I messed up my calculator. All right, so that should be our correct answer. So what does that mean my side D is equal to if I wanted to find that?
36.
Minus 8, which would be 28.
Yeah.
So this means that this side is equal to 28. That looks like it makes sense. Okay, how do you guys feel about these type of questions with the side splitter, right? As long as we know our equation and which one we're going to be using, we can go ahead and do that, okay? We're going to do one more example, and then I think, depending on if we have any more time left, we might do one more triangle example. I just want to keep doing examples so we can get some practice with it. Okay, so let's go ahead and pick one of these last four. Last person I asked was Chase. 1, 2, 3, 4. So Lakely, which triangle or pair of triangles do you want to do? You want to do the top left, top right, bottom left, or bottom right?
Either top right or bottom left.
Say bottom left.
Bottom left. All right, we're going to do this triangle down here. All right, so we need to figure out that missing variable x, which is the whole distance. So again, what would be this distance right here, from here all the way here? In respects to x, and the x what?
A.
I'm
Oh,
talking about
3.
right, x minus 3. Here we go. So good. This would be x minus 3. Okay, and now we can start labeling our letters if you would like, right? We already have this whole side as x, so I can label this whole side as y. I'm going to label this bottom of the smaller triangle A, this 3b, this 8c, and the 4 my d.
Does it matter what order that those are in? Does it matter like the
Like
numbers
the
have to
A,
be
B,
the
C?
same letters? Yeah. Or,
Not necessarily. The letters are just a way to connect this triangle to my original equations I have up here. Because these are the letters I used for my original equations.
okay.
Okay, but if you are able to identify them without the letters at all, you don't even have to use the letters at all. You can just be like, okay, I know this side has to be over this side, and this side would have to be over this side. So, does that answer your question about
Yeah.
whether we need to use it or not? Okay. So, I'm trying to find my whole distance x, so that means I'm going to either use my equation for triangle 2 or my equation for triangle 3.
Well, I use 3 because we're trying to find A.
Okay, so if we go over, are we trying to find A or are we trying to find x?
Well,
We have to find A to find X.
that's what I was.
Okay, so you guys want to do it that way, with finding A before so we can use to find x? That is perfectly fine. I think that is amazing. So with this, actually, we're able to set up an equation with triangle 1, right? Where we can just use A over B and C over D. Because we have our A and B and our C and D. So let's go ahead and do that. Oh, you guys can't see it. Sorry. So we have our A and our B and our C and our D. So let's do A over B must be equal to C over D. Okay, A is equal to x minus 3. B is equal to 3. This needs to be equal to 8 over 4. What does 8 over 4 simplify to, actually? Not 1/2, to 2. So this is actually going to be x minus 3 over 3 is equal to 2 over 1. And we can do our cross products now. Okay, I'm going to bring this up over here. So we will have x minus 3 times 1, which was just x minus 3, is equal to 2 times 3, which is 6. I got to solve for my x. I'm going to add 3, and I get that my x is equal to 9. So this whole distance is actually equal to 9. So did we even need to solve for a to solve for our x? No. Since we know that this distance was the full x minus our 3, we just use that distance to solve for our x. That is an awesome way to solve this question. Nice. I'm glad that we saw that. Thanks, Brinley, for recommending that, x minus 3. All right, what time is it? All right, so we have 5 minutes. We are going to do one more triangle similarity. One more. We got to keep going with this practice. Yeah, I'm going to do it. If you want to follow along, that's up to you. Okay?
Can we do the, I think, yeah, you said it's
Which one do you want to do, Chase?
Hold on, I wanted to see it. Hold on, I got to go back to the page.
Oh, you're fine. So our only other options are D, F, and then these bottom two triangles, if you want to do those two.
I want to do the, either, what? One of those. Wait, what?
Either D or F.
Oh, we're doing those ones?
Yeah, triangle similarity.
I don't know. That one. F.
F? Alrighty. So for F, we have all of the sides, right? We have all the sides. We just need to go ahead and put what these distances are equal to. So 2 plus 3 and 1/3 is 5 and 1/3. I'm going to put a plus in between, so I don't think that's a multiplication. That's just me, though. So 5 plus 1/3, and then 3 plus 5 is equal to 8. So we now need to do our corresponding sides, which would be AB over AP, and it must be equal to AC over AJ. So this would be 8 over 3 must be equal to 5 and 1/3 over 2. I'm going to multiply this by 3 so that I get rid of my third. So 15 and 1/3 times 3 is 16. So it'll be 16 over 6. I can divide those by 2. So that I get 8 over 3. So we do, in the long run, get the same proportions. And just like with E, this angle A is congruent to angle A. So you will have a review packet that has questions just like this that you can use on the test if you complete it. So our similarity type is what?
I got side because we have.
Oh, we have 3 and 8. So let's see if 8 over 3, oh, that's equal to 8 over 3, right? Nice. So actually this one is just side similarity. But it can also be side angle side similarity. Both of those indeed do work. Right, and this was BC over PJ. Nice. Thanks, Brinley, for showing me that. This one could be multiple ways. Our similarity statement is triangle APJ is similar to triangle ABC. My pen's running out of ink. Crazy. Alrighty. So this is your 2-minute warning. Thank you guys for a good day of notes. You can go ahead and clean up your area. Tomorrow we're going to do a couple more practice examples.